Beneath the serene beauty of Yellowstone National Park, a slumbering giant rests, waiting for its moment to awaken. A supervolcano, capable of eruptions thousands of times more powerful than ordinary volcanoes, lies hidden beneath the park's geysers and hot springs. This colossal force has shaped the landscape over millennia. These geothermal wonders are a constant reminder of the immense power that lies just below the surface. The vibrant colors and dynamic activity are both beautiful and ominous. Yellowstone Supervolcano is a force of nature that commands our attention. Its potential to alter the course of history is undeniable. Understanding its history, its behavior, and the potential consequences of its awakening is crucial, not just for those who live nearby, but for the entire planet. Scientists are constantly monitoring and studying this geological marvel. The science is clear. Yellowstone will erupt again. The data collected over the years points to an inevitable event. The question is not if but when. This uncertainty drives the urgency of ongoing research and preparedness. And while the odds of an eruption in our lifetime are exceedingly small, the potential consequences are so vast, so globally significant, that we cannot afford to ignore the giant in our backyard. The impact would be felt worldwide. This essay explores the science behind Yellowstone Supervolcano, examining its history of eruptions, the latest scientific data, and the ongoing efforts to understand and mitigate the risks and the potential impacts of a future eruption. Join us as we delve into the mysteries and realities of Yellowstone's volcanic giant. Supervolcanoes are not your typical volcanoes. They are colossal, both in size and in the magnitude of their eruptions. They are defined by the sheer scale of their eruptions, which dwarf those of regular volcanoes. Capable of ejecting over 240 cubic miles of material in a single event, these eruptions can have global consequences. These eruptions are not isolated events but part of a long cyclical process that spans millions of years. Yellowstone Supervolcano, for example, has experienced 3 major eruptions in the past 2.1 million years, each more powerful than the last. Each eruption forever altered the landscape, leaving behind massive calderas, which are essentially giant volcanic craters. These vast craters are formed by the collapse of the Earth's surface following an eruption, creating a dramatic change in the terrain. The first of these colossal eruptions occurred 2.1 million years ago, marking the beginning of Yellowstone's explosive history. This was followed by another massive eruption, 1.3 million years ago, continuing the cycle of destruction and creation. The most recent major eruption took place approximately 630,000 years ago, forming the Yellowstone caldera as we know it today. This caldera is a testament to the immense power of these eruptions and their ability to reshape the landscape. These eruptions were not isolated events, but part of a long, cyclical process, a fiery heartbeat that has shaped Yellowstone for millennia. Understanding these cycles is key to predicting future activity and mitigating potential risks. Scientists continue to study Yellowstone's geothermal activity to better understand its rhythms. By monitoring these natural processes, we can gain insights into the future and prepare for the potential impacts of another supervolcanic eruption. Imagine a force so powerful that it could blanket thousands of square miles in volcanic ash, transforming the landscape in an instant and altering the course of history. This force is capable of plunging the Earth into a volcanic winter, a period of significant cooling caused by volcanic ash and droplets of sulfuric acid obscuring the sun. This is the legacy of Yellowstone Supervolcano, a sleeping giant beneath one of America's most beloved national parks. The eruption 2.1 million years ago ejected an estimated 590 cubic miles of material, an amount so vast it's almost unimaginable, blanketing much of North America in ash and transforming the continent's ecosystem. The eruption 1.3 million years ago, though smaller in scale, still ejected a massive amount of material, reshaping the land and atmosphere, leaving behind the Henry's Fork caldera in what is now Idaho, a testament to the power of these ancient eruptions. And then there was the most recent super-eruption, 630,000 years ago, a cataclysmic event that reshaped the region. This eruption formed the Yellowstone caldera, a massive crater 30 by 45 miles across, a geological scar visible even today. The eruption ejected an estimated 240 cubic miles of material, a volume that defies comprehension, covering much of North America in a thick blanket of ash. affecting climates and ecosystems far and wide. These past eruptions serve as stark reminders of Yellowstone's raw power, a force of nature that has the potential to change the world as we know it, a power that has shaped the landscape and influenced the course of life in North America for millions of years, leaving an indelible mark on the planet. While the prospect of a super eruption captures the imagination, Yellowstone is a dynamic system, constantly shifting and changing. The heat from the magma chamber below fuels a network of hydrothermal features, including geysers, hot springs, mud pots, and fumaroles. These features are a constant reminder of the immense power that lies just below the surface. They also serve as a release valve, a way for the Earth to vent some of the heat and pressure building up beneath Yellowstone. However, this release can sometimes be dramatic. Hydrothermal explosions, while much smaller than volcanic eruptions, can still be incredibly powerful, ejecting boiling water, steam, mud, and rocks into the air. These explosions are a reminder that Yellowstone is a living, breathing system capable of both awe-inspiring beauty and sudden, violent outbursts. Section 5. The Biscuit Basin Incident. On July 23, 2024, a stark reminder of Yellowstone's volatile nature shook Biscuit Basin. A hydrothermal explosion, unrelated to volcanic or seismic activity, ripped through the area, forever altering the landscape of this popular tourist destination. The explosion ejected rocks up to 3 feet wide, destroying sections of the boardwalk and damaging nearby thermal pools. The aftermath of the explosion revealed the raw power of these events. Black diamond and black opal pools, once vibrant and clear, turned murky and overflowed into the Firehole River. The boardwalk, once teeming with visitors eager to witness the basin's geothermal wonders, lay in ruins. The Biscuit Basin incident served as a stark reminder that even in the absence of a volcanic eruption, Yellowstone remains a place of immense power and unpredictable forces. Section 6. The Watchers Monitoring Yellowstone's Pulse. Given the potential global consequences of a Yellowstone eruption, scientists keep a watchful eye on the supervolcano. The Yellowstone Volcano Observatory, a collaboration between the U.S. Geological Survey, the National Park Service, and several universities, continuously monitors Yellowstone's activity. Using a sophisticated network of seismometers, GPS stations, and gas sensors, scientists track even the slightest changes in the Earth's crust, looking for any signs of unrest. These instruments provide a constant stream of data, allowing scientists to detect even the smallest earthquakes, ground deformation, and changes in gas emissions. This data is crucial for understanding the behavior of the supervolcano and for providing timely warnings in the unlikely event of an impending eruption. Section 7. Mark Stelton, A Voice of Reason. Amidst the sensational headlines and doomsday predictions, Dr. Mark Stelton, deputy scientist in charge at the Yellowstone Volcano Observatory, remains a voice of reason. Dr. Stelton emphasizes that the current level of activity at Yellowstone is normal for a caldera system. He points out that the magma chamber beneath Yellowstone is only about 5 to 15% molten, with the rest being solid rock. While a large eruption at Yellowstone is theoretically possible, Dr. Stelton explains, it's not something we expect to see anytime soon. The system is currently in a state of equilibrium, and there are no signs of an impending eruption. His words provide a much-needed dose of perspective, reminding us that while Yellowstone is a force to be reckoned with, it is not a ticking time bomb. Section 8. The Day the Earth Shivers, Potential Impacts. While the probability of a Yellowstone supereruption in our lifetime is exceedingly low, the potential consequences are so significant that they warrant careful consideration. A supereruption would be a globally catastrophic event with far-reaching impacts on climate, agriculture, and human civilization as we know it. One of the most immediate impacts would be the widespread ashfall. The eruption of Mount St. Helens in 1980 deposited ash over a relatively small area, yet it disrupted air travel, caused widespread power outages, and damaged crops. A Yellowstone supereruption would dwarf the Mount St. Helens eruption, potentially blanketing much of North America in a thick layer of ash, crippling infrastructure, disrupting agriculture, and posing significant health risks. Section 9. Conclusion. Living with a supervolcano. Yellowstone supervolcano is a stark reminder of the immense power that lies beneath our feet. It is a force of nature that has shaped the landscape, influenced the course of life, and continues to captivate our imaginations. While the probability of a super eruption in our lifetime is low, the potential consequences are so significant that we cannot afford to ignore this sleeping giant. The continuous monitoring efforts of scientists at the Yellowstone Volcano Observatory provide us with invaluable data, allowing us to better understand the behavior of this complex system. While we cannot predict the exact timing of future eruptions, we can continue to study, learn, and prepare for the eventual awakening of the giant beneath Yellowstone. For now, we live in a period of relative calm, a time to appreciate the awe-inspiring beauty of Yellowstone, while acknowledging the immense power that lies just beneath the surface.